In quarter two, we produced over 50% more 4680s than in first quarter and continued to see cost improvements. In July, we entered validation of vehicle testing for our first prototype Cybertruck produced with in-house dry cathode 4680 cells, a major cost reduction milestone once ramped, Tesla wrote in its second quarter 2024 update letter. Along with this announcement, Elon has also announced plans to produce their 4680 dry cathode batteries at a whopping 72 gigawatts an hour by 2025 and around 650 gigawatt hours by 2030. It's unimaginable that Elon's 4680 dry-electrode bomb blew up this much. So, how groundbreaking is this new battery technology, and why is Elon so confident about it? How will the next-gen 4680 dry-electrode batteries improve Tesla 2025 models? Dry battery electrode technology offers a cutting-edge alternative in the battery industry, utilizing a powder-to-film process that saves time, energy, and space compared to traditional wet coating methods. Despite the challenges of the dry coating process, dry-electrode 4680 batteries remain a smart choice in the current landscape, offering advantages over conventional methods in terms of both production and performance. One of the biggest advantages of Tesla's 4680 dry-electrode battery is its superior energy density, boasting an increase of up to 10%, with figures ranging from 262.5 to 300 watt-hours per kg, which is 1.2 times higher than its previous 4680 version, and it's even double that of the lithium iron phosphate with 160 watt-hours per kilo, or 1.17 times that of BYD's Blade battery. The dry battery electrode process bypasses the need for slurry creation and drying, enabling a denser packing of active materials within the electrodes. This gives us a higher energy density, meaning that these batteries can store more energy within the same volume, extending the range of vehicles like Tesla Model Y, for example. Up till now, when applying the new 4680, Model Y is the first car to break the record in the US because no other electric car model in the sport utilities segment has an operating range of up to 500 kilometers. It's more than 1.5 times faster than the present version with 320 miles and 20 kilometers further than Volkswagen's ID4 Pro S version, Hyundai's Ioniq 5, or Kia's EV6 with an operating range of 480 kilometers. Even the Nissan's Leaf only has about 360 kilometers of range, which is 140 kilometers lower than the 2025 Tesla Model Y. The power capacity of the new 4680 is another breakthrough, delivering 5 times the power of 2170s while only changing the outside dimensions. By integrating a silicon and carbon anode, the energy density sees a further increase of up to 20%, potentially passing the 300 watt-hour per kilogram. This technological advancement directly translates to superior performance, as seen in Tesla's Model Y, which can now go from 0 to 100 kilometers in just 3.5 seconds. That's a major leap up from previous iterations, which take about 6.5 seconds to hit the same speed. Charging times are also another area where 4680 cells excel. The high energy density facilitates faster charging, cutting down on charging times to just 10 minutes at supercharger stations. That's a big-time improvement that triples the speed of current charging rates with 30 minutes. This enhancement is all made possible by structural changes in the 4680s, including the adoption of the all-flag design, which optimizes high-speed charging by accommodating the demands of advanced material systems. Have you heard of the all-flag design in battery manufacturing? If you'd like to discuss this interesting design in more detail, please leave a comment yes below this video. We'll meet again in a video as soon as possible to discuss more about this topic. In addition, safety remains a cornerstone of Tesla's design philosophy, and the cylindrical structure of the new 4680 batteries offer a robust thermal management, and that's a critical factor in preventing thermal runaway. When the new dry-electrode 4680 significantly enhances thermal management capabilities with the dry-electrode process allowing for a thicker electrode, reducing internal resistance, and then generating less heat during operation. Meanwhile, the original 4680, while offering improved energy density and power output compared to older formats like the 18650 and 21700, had standard thermal management capabilities. It relied on a combination of internal cooling ribbons and external cooling systems, which provided sufficient heat dissipation but did have those limitations with rapidly managing thermal loads during extreme use cases. The inherent safety advantage combined with the superior performance and efficiency of the dry battery electrode technology positions Tesla's 4680 dry-electrode battery-equipped vehicles like the Model Y and the impending Cybertruck among the market leaders in EVs. Here we have an interesting question for you. Why doesn't Tesla's 4680 dry-electrode battery use graphene electrical conductors instead of something like silicon or carbon? Anyone studying batteries has to acknowledge the remarkable advantages of graphene. With a thermal conductivity ranging between 3 to 5,000 watts per meter Kelvin at room temperature, graphene far surpasses the thermal conductivity of graphite, which is about 2,000 watts per meter Kelvin. Its immense potential in various fields, including batteries, cannot be overlooked, and its Tesla's 4680 electrodes is not out of question. However, graphene costs a lot. It's pretty expensive. Currently produced at around $200,000 a ton, it's over 9 times more costly than nickel, which is about 22 grand a ton, and 2.9 times more expensive than cobalt, which is about 70 grand a ton. This high cost makes large-scale production of high-quality graphene for battery manufacturing a pretty big challenge. As Elon's research into 4680 batteries, achieving consistent quality and cost-effectiveness at scale becomes critical. Furthermore, integrating graphene into the current dry electrode process for the 4680 may require substantial modifications to existing manufacturing equipment and processes, a task far from simple. In addition, graphene's performance in batteries does not always align perfectly with theoretical expectations, and it may not be fully compatible with materials Tesla's currently using in their 4680s. How does this next-gen 4680 reduce manufacturing costs while increasing production speed? The truth is that reducing costs is the foundation for upping production speed. Elon, along with the implementation of various advanced technologies in the production of 4680 dry electrode batteries, is driving a significant 56% reduction in production costs. This achievement is the result of several factors. First, the larger size of the 4680 compared to the standard 2170 allows for more energy storage with fewer cells, and this translates to less material used per unit of energy storage. Tesla estimates that the 4680 will cut material usage by 14%. Then, the advantages of dry electrode technology come into play. This dry electrode in the 4680 streamlines the production process significantly. By eliminating the drying and solvent steps, the number of necessary manufacturing stages is reduced, boosting efficiency and shortening production time. Additionally, the absence of solvents minimizes waste and the challenges associated with solvent disposal, leading to less material and a more environmentally friendly process. In contrast, the wet electrodes in the 2170 battery require solvent and a drying phase, which adds complexity and lengthens the production process. This method also demands more extensive infrastructure. Moreover, the use of solvents increases the potential for material waste due to the need for solvent recovery and disposal, and that's costly and bad for the environment. Moreover, Tesla's automated up to 80% of its production processes, both in battery manufacturing and automobile assembly. The large size and straightforward design of the new 4680 make it highly compatible with automation. Tesla is heavily investing in automated production lines for the 4680s, including the use of Tesla Bot, leading to maximum savings in labor costs, better utilization of existing resources, and increased production efficiency, all while ensuring higher battery quality. Thank you. An interesting aspect of the new 4680 battery production is its ability to maximize the use of raw materials, achieving nearly 98% utilization of input materials. This efficiency cuts input costs and minimizes waste, contributing to overall cost savings and environmental sustainability. Tesla Model Y is a prime example to give us a more realistic look at how cost savings in manufacturing affect the final price of an EV. Calculating the price of a Tesla Model Y long-range rear-wheel drive reveals a striking scenario. Okay, so the current price stands at $31,490, but with a 56% reduction in production costs, that estimated final price goes all the way down to $17,615. Whoa. Although this is just an estimate based on a reduced selling price corresponding to reduction in production costs, the reality, we cannot deny that the selling price could change due to many other factors like market competition, tax policies, transportation costs, but these are only insignificant secondary factors. Still, how great would it be if we paid a price lower than a robo-taxi, but got an SUV that meets all your family's daily activities, from commuting, travel, entertainment, more? In addition, to increase the production speed, Elon's employed methods that few could have seen coming. In the battery manufacturing process of the new 4680, he simplified the battery management system to scale up production. For Tesla, smaller capacity primarily refers to individual small cylindrical cells. That means achieving specific power performance requires a large number of these cells. For instance, a Tesla Cybertruck battery pack with a max capacity of 123 kilowatt-hours would need over 11,000 cells of the 2170 type and 18,650 cells of the 18650 type. The high number of cells presents a significant thermal management challenge for the battery system, and that's why many automakers have just avoided these types of cells. However, with the advent of the new 4680, the required number of cells has been cut to just 1,278. It's impressive that Tesla saves up to 17,300 cells if the Cybertruck utilizes the new 4680 batteries. This cut in cell count improves space utilization within the battery pack and a significant simplification of the battery management system, which addresses heat dissipation issues in the large cylindrical batteries. To meet the massive demand for batteries in the production of Tesla's latest models, specifically Model Y and Cybertruck, Elon announced that by leveraging all the advantages of the new 4680, the company will achieve a production rate 5 times faster than the previous version, reaching 20 gigawatt hours a year. By the end of this year, Tesla aims to hit 7 gigawatts an hour. How did Tesla tackle the bottleneck in 4680 battery production? Tesla's revolutionizing battery production through a series of advanced manufacturing technologies and strategic partnerships. In 2022, Tesla invested $3.6 billion in battery research and development, with a significant focus on enhancing automation systems. This investment supports the deployment of cutting-edge technologies such as Tesla Bot, which performs critical tasks, including transportation, assembly, and welding within the battery production line. Looking back at the difficult period before, early in the production of the 4680 battery, Tesla did struggle with the manual production process, with more than 60% labor and only 40% of the process being automated, and that led to delays and inefficiencies. The manual handling of battery components resulted in higher error rates and just slowed things down. Therefore, the company's automation strategy extends to automated transportation systems, quality inspections, and packaging processes. By leveraging AI and machine learning, Tesla is able to analyze production data, predict potential defects, and optimize manufacturing processes. This technological approach aims to reduce manufacturing defects to just 10% by next year, significantly improving the reliability of their battery production. Moreover, Tesla's adoption of dry-electrode coating technology represents a breakthrough in cutting manufacturing costs and upping production efficiency. This technology enhances the output of production lines, and that allows Tesla to better meet the growing demand for EVs. Partnerships with industry leaders like Panasonic and LG can further bolster Tesla's capabilities. These collaborations enable the exchange of critical knowledge and expertise in dry-electrode 4680 production, reinforcing Tesla's position at the forefront of battery technology innovation. Tesla has almost solved the resource constraints to meet the growing demand for its advanced 4680. The most sensible initiative for the company is to leverage the resources available, investing more into new and existing factories. Gigafactory in Texas is already up and running and making 4680 batteries on a major scale, while Gigafactory Nevada is doing upgrades to enhance their 4680 production. Additionally, Berlin in Germany, which is also nearing completion, is getting ready for use. To mitigate potential raw material shortages, Tesla's proactively signed contracts with suppliers of lithium, nickel, and cobalt across various countries. This diversified approach ensures a stable and reliable supply of essential materials for 4680 battery production. Elon, who's known for his strategic approach, has leveraged cutting-edge production methods and technologies to develop 4680 dry-electrode battery with notable achievements of battery technology. The integration of these batteries into new models has led to a 20% improvement in energy efficiency compared to previous technologies. The batteries also offer a 20% increase in energy density, extended lifespan, and reducing charging times to just 10 minutes. Furthermore, Tesla has managed to lower production costs of 4680 batteries by 65%. Incredible! And that contributes to reduced electric vehicle prices and enhancing their market appeal. On top of that, Tesla's demonstrated exceptional production efficiency. By October last year, the company was making 1,000 4680s every hour, tripling the 3,000 batteries an hour the previous year. Tesla projects reaching 7,000 batteries an hour by Jan of next year, enough to support the production of around 10,000 Model Ys every single week. The company has also doubled its annual 4680 output to up to 20 gigawatt hours last year and aims for a production target of 6 gigawatt hours by year's end. How does the new 4680 battery affect Tesla's competitiveness and profitability? Tesla's introduction of the new 4680 has the potential to reshape the EV market in profound ways. Up to the end of this year, Tesla's focusing on perfecting their manufacturing process using dry-electrode technology. Meanwhile, Panasonic is expanding its production of enhanced batteries, but has not yet gotten that same level of breakthrough innovation. Contemporary Amperex Technologies companies and BYD are focusing right now on ultra-fast charging technologies, but still haven't matched Tesla's improvements in production processes. Tesla emphasizes that while the company collaborates with suppliers, it does not rely entirely on external sources for battery supplies. This strategic independence allows Tesla to maintain its leadership position in the battery and electric vehicle industries. Moreover, the market for dry electrodes, which includes 4680 tech, is expected to experience major growth. Before the end of the decade, it's expected to hit $4.4 billion, reflecting a compound annual growth rate of 22% from now through 2029. This growth underscores the significant impact that new battery technologies like 4680 are having on the industry. Tesla's progress with the new 4680 battery technology has been noteworthy. In second quarter of their 2024 update letter, the company reported a 50% increase in 4680 cell production compared to the previous quarter, along with ongoing cost improvements. They also announced the commencement of vehicle testing for their prototype Cybertruck, which uses the new in-house 4680 cells. This milestone represents a major step towards reducing production costs even more. The demand for 4680s is anticipated to surge, with estimates suggesting it'll hit around 72 gigawatt hours next year and approximately 650 by the end of the decade. Tesla is set to lead this trend, with an expected production of around 80 gigawatt hours by 2025. In comparison, Motor and Werke company is projected to produce about 59 gigawatt hours, while other companies are expected to contribute approximately 44 gigawatt hours the same year. This competitive landscape highlights Tesla's leading role in advancing battery technology and shaping the future of EVs. So, what do you think about this new battery technology that Elon's been working on? And how will the electric vehicle market explode after the launch of this 4680 dry electrode battery? We'd be happy if you leave us some comments about this, and we hope you experience the utmost relaxation after watching this video. If you do, please press the like button and join the Tesla Car World community by subscribing to our channel. Hit the notification bell icon and stay tuned for any fantastic videos coming your way. Your feedback and time are always appreciated. Thanks so much for checking it out, and we hope to see you back here soon. Until then, take care and God bless. Bye.